Okay, so we have the graph of a function. We're trying to figure out a, b, and c for our sine curve. All right, we decided we start here. It goes 0, number, 0, negative number, 0, and that's one period. So it starts here, ends here. And we determined that if you cut this in half, you go up 2 and down 2 for the graph. So we know the amplitude is 2, and that's how we found that a is 2. All right, so let's talk about the phase shift and the period. So let's do phase shift first. All right, so which direction has our graph moved? So again, if we think about a typical sine curve, which I can put one up here for us. Here's a typical sine. We start here at the origin, go up, down, and then it starts to repeat. Has our graph been shifted? Yes, it has. It has been shifted to the right, and we just have to figure out how far to the right it's been shifted. Okay, so let's look at the scale on our axis, on our x-axis. So if this is pi over 2, half of that would be pi over 4. And then half of that, which is where we are, is pi over 8. So it looks like it's been shifted pi over 8 units to the right. All right, and let's also talk about the period. So how long before it repeats? So here it starts at pi over 8, it goes and it ends down here, which, what is that? Well, this point is at x value pi over 2 plus another pi over 8. It doesn't even matter what that is. Okay. So there are a couple ways to think about the period. Right, so we can talk about this distance and then just shift it back to see actually it's a period of pi over 2. Or we can just subtract this pi over 2 plus pi over 8 minus pi over 8 to get the period. So the ending x value minus the beginning x value will tell us our period. So how long before it repeats again? Okay, that tells us nothing about A and B yet, so let's figure out A and B. Let's work with the period first because it's a little less complicated and it also only has one variable in the formula for it. Okay, so remember we have a formula for the period of our trig function, right? Remember it's 2 pi over the absolute value of b, but we've already determined b is going to be greater than 0, so it's not going to be negative. So 2 pi over b, all right, and our period equals pi over 2. So 2 pi over b must equal pi over 2, which means we can solve for b. All right, so there's multiple ways you can solve for b. I am going to cross multiply. So 2 pi times 2 is 4 pi. B times pi equals b pi. And so that means 4 equals b. All right, so our period is 4. Or not period, the letter b. Sorry, our period is pi over 2. The letter b is 4. And then finally we need our phase shift. Okay, so remember our formula for phase shift is negative c over b. We've determined that we are moving pi over 8 units to the right, so that's what it should equal. And we can use this to solve for c. We already know what b is, so I'm going to put that in there. And if I'm going too fast, make sure you pause this, re-watch it, make sure you are clear on what's happening. Okay. All right, now we can solve for c. I'm going to cross multiply again. So this will be our negative 8c, and this is 4 pi. I just need to divide by -8. C is -π/2. Now we can write down the answer to our problem. We know A is 2, B is 4, C is -π/2. So if we look at our formula, we can put down our A, which is 2, sine of B, which is 4, x plus C, which is -π/2. So this is the function that's given in this problem. All right, so this is an important thing to know how to do. So make sure you understand what happened here and how we figured out each one of these three things, because that's what helped us figure out A, B, and C. All right, so make sure that you are able to graph sine and cosine. Oops. And then can you determine a sine and cosine wave graph given a written description? So we're going to talk about more of that in class. And then can you determine the formula for sine and cosine given the graph of the function like we just did? So make sure you ask me questions if you have them. All right, and that is the end of this lesson.